All right, and now we can get started. Remember, if you have any questions at any point, go ahead and use that questions dialog and ping away, and somebody will start answering you. So this is going to be an introduction to the DMagic module. I am going to go through the module, but this is an introduction. So we're going to talk about adding source data, creating SD files, why you use DMagic, things like that. We are not going to get really deeply into the PFM file. If you don't know what a PFM is, I do get to that in this PowerPoint, but if you were hoping for a really in-depth PFM session, this is not going to be it. We will have one of those coming up in November with Duncan Malice. So an overview of what we're going to talk about today. I'm very briefly just going to mention the Fledermaus suite. We're going to review the version 7 Fledermaus workflow and where DMagic fits into that. And then we're going to go through the DMagic module. So we're going to create projects, talk about how they're organized. We're going to add some source data to the project, and these are the different types of source data that can be added to a DMagic project. And then how to take that data from source to SD, and a few other things in between, different analyses you can do, things like that in DMagic. So just briefly to go over the Fledermaus suite. The Fledermaus is a suite of software, and if you were to open your Start menu and look under Fledermaus version 7, this is the list you would see, a long list of software. And you may or may not use a lot of these different modules. On the right is a list of what each of them does. The most basic core modules are DMagic and Fledermaus. Today we'll talk about mostly DMagic, but Fledermaus is also is probably the most important module. That's where all the visualization occurs. But we do have a lot of other modules that do specific tasks, and most of them are doing tasks to prepare data to go into Fledermaus. Just quickly on the Fledermaus module, we abbreviate it often FM. So if in my slides you see an FM, that's what that means. The word Fledermaus refers to the entire suite of software, and it also refers to the Fledermaus module, which is a module within the Fledermaus suite. And Fledermaus is the main visualization module. Even if you are using DMagic and a project-based workflow like we're going to talk about today, Fledermaus is still your visualization engine. So if you want to see things in 3D or 4D, you go to Fledermaus afterwards. That's always the core engine for your data. The focus of today's webinar is DMagic, which stands for Data Magician. DMagic is a core module within the suite. You use it together with Fledermaus, and the two of them together constitute a project-based workflow. DMagic is an organization tool for data. It lets you get all of your source data into one place, see how it all lines up, and then make decisions on making SD files, gridding portions of the data, etc. In DMagic, your source data can be viewed and analyzed, and you can create SD files, PFM files, scalar files. However, all of the visualization as far as 3D and 4D visualization is done in Fledermaus. In DMagic, you have a 2D map down view, which is still very helpful, but when I say visualization, I'm usually talking about the hardcore, really good visualization in Fledermaus. Just a quick screen for you version 6 users. In version 6, DMagic was a necessary part of the workflow. You had to step through DMagic to create an SD file. We had something at that point called a shade, and you created a shade file in DMagic, and then you used DMagic to assemble the SD. We no longer have shade files. SD files are created directly, and SDs are created directly in both Fledermaus and DMagic. So DMagic no longer had that necessary function. So we rebuilt it as this project manager. And it's really geared, I would say, towards survey project management. Definitely other people use it, but it has a very hydrographic surveyor feel about it. And hopefully you'll see that as I go through it. If you're still having any problems going between version 6 and version 7, and if you're a user under maintenance, you can have one of these personalized webinar sessions where I go through and I tell you how to do things. So if you're still having issues, please send me an email and we'll set up a quick session. And there's my email, eheffron@ivs3d.com. All right, basically in Fledermaus, what we create, the Fledermaus file types, and I'm sorry for all you guys who already know this, I'll try and go pretty quickly. In Fledermaus, we create a few primary objects. The first one is an SD file, which stands for Scientific Data Object. This is the primary Fledermaus file. We also call it a data object, a surface. We call it by many a different name. It's one set of data saved in the Fledermaus format. SD files can be different kinds of data, such as a DTM SD or a point SD. The most common SD is the DTM SD, Digital Terrain Model SD, and that's what this is down here in the image. This is an example of a DTM SD file, one type of Fledermaus file. Wait for the screen to update. A second file that we create is called a PFM file. And this is probably one of the biggest questions I get. Not too much detail, but people just want to know what does PFM stand for. I don't think we say it in the manual anywhere. It's just a file extension for pure file magic. It was a cooperative agreement that we did with, I think, Naboshino to develop this format, and that is the extension they wanted to use for the file. So that's what it stands for. It's not as important as you might think. But the PFM file itself is very important. It is our way of dealing with really large data sets. It's an advanced file that looks very similar at first glance to a DTM-SD. Here's a portion down here, the bigger image of a PFM file. At first glance, it looks very similar to a DTM-SD, but it lets you access the underlying soundings or points if you're using LiDAR data. So you can select on this surface and actually bring up the soundings. It is an advanced file type used for QC and QA of multi-beam bathymetry and LiDAR for editing that data. And it cannot be created in every bundle. It's in the Fledermaus module and it's in DMagic, but the access to this functionality is not there for everybody. It's in the FM Hydro and the FM Pro bundles. So you may have Fledermaus and DMagic, but you won't necessarily have PFM functionality. We also create a file type called a scene file. That's a grouping of SD files. These are not used in DMagic at all, but I did want to mention them because they are important. All right, so what do we create these PFMs and SD files from? That would be our supported data formats. Ungridded supported formats, I have a list here, and this is just from our website. It's probably quite difficult to see. It's very small, but it is on the website. And basically, our ungridded data formats are the closest to raw that we can get from multi-beam providers. So we have the HGCS file from Keras, the generic sensor format file, or GSF, some other common ones in there, HS2 files from HiPAC, LAS files. This is ungridded data. So you'll take this data in and you can create a PFM or a DTM SD from this file. The other supported formats would be gridded formats, and here is a much easier to see list of the gridded data imports that we support. Common ones in here, gridded ASCII data, GMT grids, ArcView grids, so quite a few common formats. So if another software was used to take ungridded data and grid it out to decimate it into a smaller file, we can import that grid directly. And then other stuff we support, this is the ancillary data, and this is data you can add to enhance your visualization or aid in interpretation. Excuse me. Sorry about that. On the left, we have the ancillary data support from Fledermaus, so images, vertical images, points, and lines. And on the right, the ancillary data support from DMagic. And then in the middle I have a list, and if they're bold it means they're supported in DMagic and in Fledermaus. In DMagic you're going to add ancillary data more for the aiding and interpretation and analysis, more to give you an overview of your full data set. So in DMagic you're most likely going to add imagery. You might add vectors like ENCs or DXFs. But you wouldn't add things like vertical images. You can't add things like vertical images into DMagic. And DMagic is not in 3D, so it wouldn't do you much good to add a vertical image. But you can bring in the supporting data into DMagic and into Fledermaus. All right, so a Fledermaus Suite workflow review now that we got through the basics. You have two methods of getting data into the Fledermaus Suite. We have two basic workflows. The first one is a simple workflow, and that's mostly using Fledermaus for import and analysis. You're taking your data directly into Fledermaus, gridding it there, and creating an SD file. The other option is to use a project-based workflow, and that's the one we're going to talk about today. A project-based workflow uses DMagic to first organize and import and organize your source data, and then create SD files to go into Fledermaus. It gives you a better overall picture of your data. When you go directly through Fledermaus with the simple workflow, you have to have a pretty good idea of what your data looks like. You don't have the option to just select one portion of a data set to grid, for example. It will just grid whatever you feed it. With DMagic, you get to see the overlay of the lines and then make decisions on what you want to do with the data. If you want more information about the workflows, we did have a version 7 workflow webinar on July 29th, and that is recorded and is available. And we also had an introduction to the Fledermaus module at the end of August, also was recorded and is available for download. To review the basic simple workflow, and this is what we talked about in the Fledermaus webinar, the basic Fledermaus workflow, you take your ungraded data, you import it directly into Fledermaus, you create an SD file, and you save it as a scene. Now there's a whole bunch of stuff that you can do in there on top of that, but that's the most simple path for your data. However, we're going to be talking today about project-based workflows. And project-based workflows, again, means taking DMagic, organizing your data, and then taking it into Fledermaus for visualization. So what does a project-based workflow mean? It means you're going to make a collection of your data for your area so that you have a really comprehensive view of all the data that you have available for a project area. You're going to add source data, and that source data is going to maintain links to the underlying true data that was used. So you'll have more information. You'll have metadata information about those files. You'll have the center tracks for multi-beam data, just a lot more contextual information about the data, and it lets you do more with it. The access to the source data allows you to use source data dependent tools. For example, the ability to plot points from the ungridded files, to view the metadata, to create PFMs, and with images to do image editing. So all of that is part of a project workflow. You're going to use this project-based workflow when you plan to be returning to a set of data. You want an organized project for an area that you can keep coming back to create multiple data objects, different products, visualizations to go to different people in your organization, etc. Reasons you would go project-based: you have a lot of files, either of a single or multiple types, and you want to see them all. You want to see how they relate to each other, and you want to keep them organized. Your data covers a large area, and you may not need to grid all of those files, or you might want to have the ability to make a decision to only grid certain areas. If you're uncertain about the data density of your ungraded data or how large your data set is, you would probably prefer to use DMagic. It gives you a little more options to help you analyze that kind of thing, especially data density. You plan to reuse the source data to make different products. Like I said, you want to keep returning to this data set and maybe regridding at a different resolution for a different client. And the last reason, you want to do something that can't be done directly in Fledermaus. And I have a list of those on the next slide. So things that can't be done directly in Fledermaus. So these are things that maybe wouldn't necessarily make a project, except for you kind of need to do some of these things, and they don't happen to be in Fledermaus. The first one is image editing. We used to have a module called Image Viewer. That got put into DMagic. The Image Viewer functionality lets you do some basic image editing, like cropping, adding transparency, reprojecting images. All of that got put into DMagic, so if you want to edit images, you do have to make a project. If you want to export ungridded or gridded data in a different format, such as XYZ, you have to do that directly in DMagic. If you're unsure of your data density and you want to plot the ungridded points, also in DMagic, the PFM functionality is all in DMagic, and that includes creating PFMs, unloading, updating PFMs. Everything for the PFM is handled in DMagic. If you want to compute rugosity and slope, and that's one that should definitely be in Fledermaus but is not at this point. So if you want to use either of those algorithms, you do have to use DMagic and therefore create a project. And finally, if you want to do interpolation or resampling on your grids, so interpolation pretty much means filling holes in your grid, and resampling means downsampling to a lower resolution. Those two algorithms are also only in DMagic. And just an image of a basic project-based workflow. You'll create a project in DMagic. You'll add your source data, and that includes ungraded data, grids, image, and vector data. So this is all under organization. Within DMagic, you can create the PFMs, DTM-SDs, GeoImage-SDs, and points and lines. And then finally, all of that will go into Fledermaus for visualization. So very basic workflow diagram. There is a lot that can go on in here and in here before you get into Fledermaus. Just a brief word on georeferencing in DMagic before we get into it. When you build a DMagic project, you are going to set a coordinate system for your project. The DMagic georeferencing is project focused. So you're going to create a project, and the first question it asks is, what coordinate system is your project in? You set that project to what you want your project to be and what you want your data to come out as at the end of the day. So your source data can be in different projections. For example, it can come in as WGS84 into a project that's UTM Zone 19. It will display visually as UTM data, and if you create it an SD file, it will then be reprojected. But the source data remains untouched. It doesn't get reprojected. It's just being reprojected visually into the project. And that's what this third point is. The bounds of the source data are visually reprojected in DMagic so that you're viewing geographic data in UTM coordinates, but the original data is not altered until when you make an SD or a PFM. Then those new files that are created will be in the new project coordinate system. And then I just have a kind of an image to kind of sum that up of different things and what happens to them. So for example, if you have a set of GSF lines that are in WGS84, if you take them through DMagic and make a DTM-SD, by default they will be in Zone 19 if the project was set to Zone 19. If you only take those GSF lines in and choose to export them as ungraded data, then you'll have a choice of the coordinate system. So you can export them in WGS84, in Zone 19, or whatever you want. And when you create a DTM-SD in DMagic, you could change the output coordinate system, but it will no longer be viewable in the project. The default will be to stick with the zone projection, the project UTM zone. And here's just a list, and you can just read through that on your own. The only other one I would mention is a GeoTIFF. If you bring in a GeoTIFF, again, if it's in WGS84, and you create a GeoImage-SD, we will reproject the image to the project coordinate system. If you are using the image editor and you, say, crop the GeoTIFF and save a new GeoTIFF, it will be in the source coordinate system of WGS84. So if you're just altering the original data set with a GeoTIFF and making a new GeoTIFF, it will maintain the source coordinate system. All right, so that's enough PowerPoint for now. Let's get into going through the software. If there's any questions, this is a good time. But if I don't hear from Josh, I will assume that I should keep going. All right, looks like you all are following along pretty well. So before we start building our own project, I'm just going to bring up a already created DMagic project to give you a feel for where we're going. So this is what DMagic looks like, the DMagic interface. On the left there is your source data, and we're going to go through all this as I build a project. On the left is my source data. Below the source data are Fledermaus SD files that were created from that source data. In the center I have the visualization area, and then on the right we have some different modes, and I'll go through those in detail. And this is just a good example of a project. It has a decent amount of data in it. It could have some more, but just to give you a feel for what you see when you have a DMagic project. First, if I collapse all these nodes, here's the list of all the source data you can have in DMagic, and if you hit the tree view, then you'll get all of the files that fell under that type of source data. So here I have some GSF data and some Consberg.all data. The GSF data is organized into different dates. If I select on the GSF folder, those lines will highlight here in the view. And if I zoom in, you can see that the ungridded files are displayed as center lines for the multi-beam track. So that is how your ungridded data will display in DMagic. With DMagic, when it first is imported as source data, you're going to see the source data as vectors. You're just seeing kind of the metadata or the extent of the data in your first view. And that lets you take a look at how things fall together without necessarily making a grid or an SD file out of them yet. So you can see where the lines are. And it's quite helpful, especially if you look at this case. I have all of these GSF files, and then somewhere in these GSF files there's these lines up here. Now if I was creating an SD file, it looks like they were doing a patch test there. If I was creating an SD file, if I just blindly gridded everything in that GSF folder, I'd have a nice Fledermaus SD of this area, and then I have this random chunk of data floating around up here and taking up precious grid space. So by bringing it into DMagic first, I could see where those lines are, and I can say, okay, which lines are these? When they're yellow, they'd be highlighted, and I can go through the tree list and find the lines where they are, and then I can choose to leave those out of my gridded data set. Just to zoom out, the other boxes are the displays for other kinds of source data. So let me just collapse the ungridded, turn those off. The grids are displayed as light pink boxes, so let me turn off everything else. You could probably barely see that, but there's a very light pink box here, and that is the extent of this grid, which is a topo lidar XYZ grid. Images by default are blue boxes, so if I turn on the images and zoom out, there's two big blue boxes. Those are the extents of two charts that I have. I have a full chart for the area and then a smaller one, and they are the blue boxes. And vectors, the display for their extents is a dark pink box. So you bring in source data and you'll get this kind of vector display, and then you'll go through and make it into SD files. But that's what we're going to do together. So I just wanted to give you a feel of what a project looks like. Once you bring in the source data and you go through the processes, you'll start to have SD files down here. These are SD files that can go into Fledermaus. Once they're created, you can turn those off and on. By keeping them off, things move a bit faster and you're less likely to clog up your memory. So here I have a really big chart that's quite large. If I turn that chart off, I also have an SD file of the main harbor there. So I do have Fledermaus SD files that I've created, and they're available to view in the project too. Okay, so that's where we're going. I'm going to minimize that project, and now we're going to build one from scratch, creating the project, setting the coordinate system, adding the source data, and then moving to SD. So I'm going to open a new instance of DMagic. And I'm going to close this other one to prevent any problems. All right, so you open DMagic from this icon on your desktop. If I hold on there, right there, it's a little top hat. You can also go to Start, All Programs, scroll down, Fledermaus version 7, and DMagic. So that's two different places you can access DMagic. When you open up DMagic, Again, the main area in here, your visualization area, is where you're going to see your source data and your other files as you create them. Under source files, you'll see listed the source data that you bring in. Under the SD files, you'll see listed any SD files or PFM SD files that you create. And on the right, we have a few different option keys, which I'll step through. Up here we have the menu bar, and at the bottom left where it says information not available, that's your geospatial information bar. Sorry about that. And when I'm scrolling, once we have data loaded and I'm scrolling, you'll see coordinate information down here. Right here in this box, this is the object attributes area, and once a Fledermaus SD file is created, you can see different attributes for that SD here. But when you just have source data loaded, you won't use this box at all. Alright, so getting started, the first thing you have to do when you open DMagic is create a project. You go to File and Create Project. What happens when you create a project? When you create a project, all you have to do is give it a name, you have to set the location for the project, and you have to give it a coordinate system. Once you do this, it's going to make a set of folders, a project hierarchy to allow you a location to store data if you choose. It's also where new SD files that you create will be written to, and it's where your metadata for your project will be stored. So I am first going to set my location. So you browse, make sure, by default it goes to your C drive, to a default folder called FM data. But I prefer to change the location to somewhere else. So I have on my C drive a data folder, version 7 data, and then I have a folder called projects where I like to keep these things. For the name of your project, you can name it whatever you want. I choose to do the name of the area, so Portsmouth. I always put something about the grid zone or the projection that I'm going to use for the project. I am going to have this one in UTM 19. That is the coordinate system for the area that we're in. And I like to put PROJ for project at the end of the file. The reason I do this, when this file is created, it looks like a normal file folder in Windows Explorer. So sometimes when you're scrolling through Windows Explorer looking for things, it doesn't really stand out visually as a project. And this just kind of helps point you to the fact that it is, in fact, a DMagic project. So I've named my project. The next thing I want to do is set the coordinate system. And this is going to be in UTM zone 19. With the coordinate systems, your common coordinate systems are listed in this drop box here. So I have up here the common latitude, longitude, decimal degrees coordinate system. So unprojected data. You only really see the datum here, WGS 84, NAT 83. Under that, you have the UTM zones with the WGS 84 datum. So common UTM zones here. If your coordinate system does not fall into one of these categories, all you have to do is hit the select box, and that will take you to the full coordinate system library. So you can pick whatever your coordinate system is. You can also choose to import a coordinate system, and we read the Esri PRJ files, or you can edit, create one if you're so inclined to do so. Mine is a common coordinate system, so I'm going to just use the down arrow and go to 19 north. For vertical datums, leave them undefined for now. This is something that we're in the process of really implementing into the software. It's only partially there. Some people do have a need to set this, but it's very few people who are trying to do something specific. So unless you know you're one of those people, I would leave this undefined for the time being, and that's the vertical datum. And sometime in the future we will be able to set vertical datums and reproject vertical datums, but we cannot do it at the moment. So that's all you do to start your project. You say OK. Visually, the only thing that will change, you'll have your project title up here. But what's created, I'm just going to bring up the folder where I created that project and show you what it looks like. So I'm going to bring up my projects folder in Windows Explorer. All right, and that's actually not the right one, so let me try again. So in my projects, I have my Portsmouth UTM 19 North PROJ. And you can see, just looking at this, it just looks like a standard Windows folder. So you have no way of really knowing it's a project unless you differentiate it somehow. If I click on that, you'll see all the different folders that are created by default as part of a project. So briefly, to step through these folders and what they mean. First, the two easiest, history and workflow, they mean nothing right now. They are placeholder folders for work we hope to do in the future. The history folder, at some point in the near future, the plan is for it to hold all your PFM building history, anything that's been done to files, PFM audit files, pretty much anything that's been done in a DMagic project while you were working within it. But right now, there is nothing in there at all. Workflow, also a placeholder folder, and there are no immediate plans for what's going to happen with that. More important folders, your metadata. This will store the metadata for the project. So as you bring in source data, little metadata files are created. And for each file you bring in, there's going to be 3 little files. There's a .met, a .full, and a small Fledermaus SD file. So they all are, the .met and the .full are basically XML files with metadata information. And then the SD file is just a visual display. It's the center line for multi-beam data, just a tiny little file that's loaded into DMagic. The PFM and SD folders, these folders are where new SD and PFMs that you create in the project will be stored. So by default they're empty, but if you create a new file, they will by default go into those folders. The source folder, if you open it up, there's 4 folders inside: grids, images, ungridded, and vectors. Those are the 4 types of source data we support. There's nothing in these folders right now, and nothing goes into these folders by default. So when you add source data into your project, when you say add ungridded data, nothing's written into this ungridded file folder. The reason these folders are here, you could choose to copy your source data into these folders to further keep things organized, but none of your data is copied there by default. When I add ungridded data to my project, in the metadata there's a link to where that data resides. If it's not in this folder, that's fine. But if I move my project, it's more likely that you'll have a broken link because it's not quite so self-contained. So if you really want to organize yourself, you could choose to copy your ungridded data into this folder and then add your source data from there. But if you are like most survey companies, you have your data exactly where you want it and you don't have room to replicate it. So that is a choice, but nothing is put into these folders by default. All right, so that's all of your project folders that are created, and of course you get a project XML with some basic XML metadata for the project. I'm going to minimize that, and I'm going to start adding some data. So the first data set you might add is some ungridded data. You can add source data in 2 ways. There's usually 2 ways to do everything in DMagic, either through the menu options or by right-clicking somewhere in the interface. I'll do it both ways just to show you the different options. So you might add source data by going to File, Add Source Data. And this is your next step after making a project. So step 2, add some source data. File, Add Source Data. I'm going to first add some ungridded data. Click Next. You can choose to add file or you can add directory. If you add file, you'll just get a basic file selection interface, and you can take one or many files, doesn't matter. If you add a directory, this is sometimes the preferred option because A, it lets you not have to select 10 files. It will just take everything in the folder. Another reason why the directory option is good, it maintains any subdirectories and it keeps the folder name in the node structure once you get over here to the source files. So for example, if you have a file called GSF and in that you have your multi-beam data separated into 10 different legs of a survey, so separated by day, each of those subfolders will be in your hierarchy. If you like that, then that's the way you want to go, and it's much faster because you can add one multi-beam file directory with many subfolders all at once, all in one hit. Or you can choose the add file. It doesn't matter. This little section here is a file filter, and the way that works, if, for example, you have a file, you have some XYZ files and some GSF files in the same folder, but you only want to add the XYZ, you can add a directory, but type in .xyz here, and it will only suck out the files with that extension. Okay, so I'm going to add a directory. I'm going to be adding some GSF files. GSF files are just multi-beam files. They're pretty similar to an XYZ, but they have a lot more data stored in them. So I'm going to set up a file filter for GSF. I'm just going to type .gsf here, and it's going to just take the GSF files out of my folder. I'm going to add a directory, and in my make sure I'm in the right place. Portsmouth, I have some ungraded data and some reads on GSF. And I have a folder called Harbor Entrance. So I'm just going to get that whole folder, just selecting the directory, and click OK. And once I do that, it's just going to list all the files that are going to be loaded into my project. So you see I have, however many GSF files. The rest of the options here just lets you clear or remove certain files if you got something wrong. You can also load a file list, and that will bring in a bunch of files at once. And if you're using HIPS data, you have to use the Add HIPS Data button to access your files, or they won't add properly. You click Next. The next thing you have to do for ungraded data, you have to tell it what coordinate system the data is in. This data is in WGS84. Now, how do I know that? I know what's in my file, but a good way of looking in DMagic, there's this nice little preview source file button. If you click on that, it will load up one of the files that you've selected, and it will show you all of the columns that are available in that file. So if I scroll through, I see that it looks like the third and fourth column are latitude and longitude, and these coordinates are in decimal degrees. So that tells me that this data set is in a geographic coordinate space, decimal degrees, so it's not projected yet. It's in WGS84. So the source data is in WGS84. Again, to change it, you just select from the down arrow or go into the library. The vertical datum you leave undefined. For the input configuration, for the case of a GSF file, it knows the X value is the longitude column, the Y value is the latitude column, and the Z value is the depth. If you have a generic XYZ file, for example, that may not be the truth. And if you need to change those mappings, you can just click on this configure button and tell it which column is in fact the X, Y, and Z values. Okay, so that's where you can set up your column mapping if you have most often a generic ASCII file is where you're going to have to do that. All right, so you just set up which columns equal what for the X, Y, and Z, and click Finish. And what it's going to do, the files will all come in under Ungridded, and when they first come in, they'll be red, and you'll see them being scanned. As they're scanned, they turn black, and if I hit my camera and zoom out, as they're scanned, it will draw the center line for the file. So I have the center line coming in, and that's about the middle of the multi-beam track coming in for each line. And as I go down, you can watch the progress of the scanning. So it goes from red to black. While that's scanning, I'll just show you some things. This gray box that starts to develop in the background, that's called the bounding box. And as you can see, that box is growing as more data comes in. The gray box will always show the bounds of all of the loaded data for the project. So as more data is added, those bounds are continuing to grow. The other thing you'll see, if I zoom in close, is that the numbers on the bounds are in fact in UTM, and that is because my project was set to UTM zone 19. So even though that source data that just came in was decimal degrees, 71 degrees by whatever, it's now visually being reprojected to a UTM coordinate system. Okay, so the bounding box and the coordinate system. Just while those load, I could talk about some other things. The camera button will always zoom you out to the full extent of the data, which are changing now. But when I press on that, it brings me out so I can get a good overview of my data. Under the camera, you have modes. The mode that I've been working in is called exploration mode, and that's just the cursor. When you're in exploration mode, certain interaction is different in DMagic. Exploration mode is how you want to be moving around in DMagic. And when you're in exploration mode, if you left click and drag your mouse, it will move your data around. So it's kind of a pan, but not really. It's more of a left click and drag your data. If you middle click, it will move wherever you click to the center of the screen. So I'm middle clicking in that block, and it will shift that block to the center of the screen. If I scroll in, it will zoom me into the data. And if you right click and drag in DMagic, you'll get a profile, but only once you've created an SD file. So that's how your mouse interacts with the exploration mode. The other modes we'll get into after we start exploring this data. This is to turn the color map legend off and on, and you'll see this white empty box here. I don't have any surfaces yet, so there is no color map, and that's why you have that blank box. And this is just a clear selection tool, which we'll talk about in a little bit. So all of my data is loaded, and if I zoom out, it might be a little tough for you guys to see, but I have a bunch of white lines, and these are the center lines for each of these CSF files. The way that they're connected to these lines that are in the list here. So you see I have an ungridded node, and it expands. The harbor entrance was the name of my folder, so that's a separate node. And then under that, I have the separate GSF files. If I select a GSF file in the list on the left, you'll see that the same file highlights in the screen. So there is a connection between those files. If I choose a file from the visualization, so if I left click on a line, similarly that line will be highlighted over on the left. So it's easy to find if you have a bad line and get it out of your data set. So now that we have this ungraded data in, I'm going to tell you what you can do with ungraded data. And there's a few things you can do with it. The first thing you might want to do, and this is something that you can do only in DMagic, if you got this ungraded data from somebody and you have no idea what the density of the data is, you can't really grid it because you don't know what to set for the cell size, and you can't create a PFM because you don't know what the bin size is for the data, how small of a cell you can set without getting holes in your data. So to evaluate that, you can do what's called plotting points, and this is a nice feature in DMagic. So if you want to see the points for each line and see how dense your point spacing is, you can select a line. I try to select just one because it is kind of intensive to plot these points. Select a line, and you want to zoom in really close to it. I usually start right about there and see what happens. So I've selected on this one line, I've zoomed in rather close, and then I can right-click on it. And when you right-click in DMagic, you'll start to access different menus once you have source data loaded. And now I have a lot of different options that are available. They're black and not gray. And the first option is to plot selected ungraded data. So if I click on that, it's going to scan through and plot the points. Now once it's finished, two things happen. It pops up a little box up here, and this is a new dialog. That's the plot points dialog, and I'm going to explain that as I go. The other thing that happens is the points are plotted. Now these don't look like points because I'm zoomed out too far, so they're kind of smeared together into blocks. So I'm going to replot them, and I can do that using this interface up here. So once you get to this point, you see that you still can't see the separate points. You can zoom in closer, real close, and then up here in this dialog that opened up, you can hit replot. Scans through again, and after this replot, hopefully you guys can see there's now separate individual little points. So these are all individual points as collected by the sonar. Each is a different hit on the seabed. So what does this tell you? Well, at this level, not much. I see I have lots of points, and I had to zoom in really close, so they're probably pretty dense. The other thing that you can use with this dialog is this grid. So if you see up here about the center, there's a little green grid box. What this does is turns on a plotting grid on top of your points and will show you what a cell of a certain size looks like. The default cell size is 25 for this grid. So if I turn on this grid, you see nothing. And the reason is, I'll zoom out, a 25-meter grid cell is much larger than the data I was zoomed into. So obviously 25 meters for this data won't work. You'll also notice that the points only plot to your zoom level, and that's so that it doesn't take forever for the points to all plot in. So I would zoom back in, and obviously 25 meters won't work. So I might update my cell size by typing in a new number. I might try 5 and click the update and see what that does. And if I zoom out, I'll see that a 5-meter cell is a little more appropriate, but I still have data that's way denser than that. So I might move my cell size to 1 and update. And I see if I look in that I still have several points in a 1-meter cell. So this tells me that for this data set, I can grid this data at 1 meter or better because it's very, very dense data. And this is just based on one line. If I selected 2 lines, the areas of overlap would probably be even denser. So this is a good tool if you're given data that you really have no idea what the resolution is, and I use this quite often. Once you're done with that plotting points dialog, it's important that you hit the Done button up here, or you can't do anything else. So once you've found a good cell size, you're happy with cell size of 1, it will remember that when you go to grid this data, or you can write it down somewhere. Just hit Done, and the plotting points dialog will go away. Alright, so that's one of the first things you can do in DMagic that you can't do in Fledermaus, and which is quite useful. Once you've done that, then you could start to grid your data. So when you're gridding data in DMagic, another reason it's very nice to have a project, you can choose to grid portions of your data, you can choose to grid a single line, or you can choose to grid all of the data that you loaded. So for example, if I, for some reason, wanted to grid just this single line, I can select on it, right-click, and say Grid Selected Ungraded Data, and it would just grid that one line of data. Now there's not very many reasons why you'd want to do that. So another thing you might want to do is select a portion of the data and grid that. You can do that with this second mode here, which looks like a crosshair under the modes, and that's the selection mode. So if I set the selection mode, if I choose that one, my cursor now changes functionality and it changes appearance. It's now a crosshair that lets me select. And using that, I can left-click and draw a box around some data. And when I do that, it's going to select any data line that falls into that box. Now you'll see it's selected all of this data that falls outside, and that's because part of each of these lines falls within the box. But if I choose to grid just this area, it's not going to take all of that outside data. So I'm going to do that. I'm going to set my selection. I'm going to say, okay, I just want to grid this area. I draw the selection box, and then I right-click again, and this time, Plot Selected Ungraded Data. Because I've selected a portion of the data, that's what it's going to grid. Or, I'm sorry, Grid Selected Ungraded Data, not Plot. So I'm going to Grid Selected. When I do this, it's going to just step me through the typical gridding wizard, and if you've used Fledermaus, this is the same gridding wizard you get in Fledermaus. So it loads the data, you click Next, and it fills in more information for you in DMagic, so there's kind of less choices you have to make. It already knows that the input coordinate system of the data is WGS84, so you can leave that be. The output coordinate system is going to default to the project coordinate system, which is zone 19. You could change this here, but it will not. The resulting SD file will not be visible in the project, so it's going to default to the project coordinate system. You click Next, and you can see most of the stuff is filled in. You pick your gridding parameters, and I'm not going to go through the gridding types. We talked about that in the Fledermaus presentation, and if you need more information on that, it's in the manual, or you can email us. But there are a few different gridding algorithms. I'm going to stick with the default of weighted moving average with the weight diameter of 3. For the cell size, it took this cell size directly from that plot points dialog. So the last option I chose, it's saying, okay, the last thing you typed in was a 1, so we're going to assume that you want a 1-meter cell. But you can change this if you want something else. If I instead, in the sake of time, choose a 3-meter cell, bigger cell size takes a little less time, I can do that. After you choose your cell size, you click Next. The next bit's a color map. You can choose one of our system color maps, but this can always be changed later, so I often leave the default. Click Next, and what do you want to create? 99% of the time you want to create a surface DTM, and this is a Fledermaus DTM SD for bathymetry or topography. A scalar is an SD for things like slope, temperature, etc. And then you give it a name. I'll call it small area, and finish. So that'll just take a minute to grid up. While it's gridding, if there's any questions or anything, I'm available. Josh, you can let me know. Again, as is typical for webinars that I do, I'm probably going to go over 12 o'clock, but I promise it will not be as long as the Fledermaus webinar that we did a few weeks ago. I suspect we'll be going for another 10 to 15 minutes. Just so if anyone has to leave, feel free. Okay, Josh tells me we're good, so I'll just wait for that to grid up and then I'll continue on. All right, and after it finishes gridding, let me just get my audience view back here. Hopefully you can see that. It's now created a new, and I'm going to switch back to exploration mode so I can move around. It's created a new SD file. The SD file is listed here under SD files. If I collapse the ungridded, I can also turn off the ungridded lines to get a feel for what I have. And I have a typical Fledermaus DTM surface. Now that I have this DTM surface, I can right-click in Profile. And this is just a normal Fledermaus SD file that can go directly into Fledermaus now. Once you have an SD file, you also have object attributes down here. And these I also talked about in the Fledermaus webinar. These are just different options for the display and the manipulation of this DTM surface. So you have things like transparency, you can drape here, you can do a lot of the same things that you can do in Fledermaus. So that's what you can do with ungridded data. You can plot the points, you can grid portions of it. You can also choose to grid the whole thing. If you have tons of ungridded data here and you don't want to mess around with the selection tool, all you have to do is select the top level. So I just select the top level harbor entrance here, and if I right click on that, I can again choose to grid those ungridded files. So you can select things in a variety of ways for gridding from the ungridded. All right, so that's some ungridded data. That's bringing it in as a source and then taking it to an SD. The next thing I'm going to bring in is a different kind of source data. I'm going to grow my project a little bit, and I'm going to bring in a grid file. So again, you can go to File and add source data, or I'm going to show you the other option this time. You can just right-click on the kind of source data you want to add. So I can right-click on grids and choose to add gridded data. And that's the same thing. You're adding the source data. So I add gridded data, and instead of bringing up that first dialog box where it says what kind, it already knows what kind. So it's kind of, you're skipping a page in the wizard. You go to Add File and just find your gridded file data, your gridded data set. So in my grids folder, I have just a nice XYZ lighter file. So I load my file up. These options are available here, but these are really for ungridded data. So you pretty much just add a file for gridded data. Once you do that, you click Finish. It's kind of misleading because it doesn't finish. It opens up another page, but it does say Finish. So once I click Finish, the next page, it says what kind of file type. It does a pretty decent job of guessing. But this is an ASCII gridded data set. You can make sure that it chose the right option. If not, pick the right option. And this is a nice list of the file formats we support. Sorry about that. I should have turned off my Skype. This is an ASCII gridded data set, so I can choose ASCII gridded. Sorry, that'll get rid of that. All right. Click Next. The next selection is what kind of ASCII gridded data is it? It is just a straight XYZ variable. Now, depending on the type of gridded data you add, these next few screens may be different. ASCII gridded data is fairly simple, so there's not very many options. If you bring in a different type of grid, you will have different options and different screens here, but they're all fairly simple for gridded data. This is an XYZ gridded data set. If the data had some header lines or a specific no data value, you can specify those there. You do want to make sure and specify header lines, because if you don't, it will screw up the gridding for ASCII gridded data that import. Click Next. With ASCII gridded data, your columns can be X, Y, and Z in that order, or they could be in a different order. So if, for example, the columns are in a Y, X, Z order, you would reorder these fields. And that's just making sure that it properly maps the data points. Click Next. And you want to set the import coordinate system of the grid. And this is the coordinate system that the data is in. This data is already in zone 19, so I leave it as is and click Finish. So it'll just take a second to load up that data set. Once it's added the grid, under my grid node, you see there is a gridded data set here. It's the ASCII XYZ, and it might be hard to see, but you can see that the bounds have grown. And this is reflecting the fact that I've added a new, larger data set. The grid data set is displayed as a pink box. So I'm zooming in the corner here, and you probably can't see, but there's a very pale pink box that happens to now match the bounds of the whole project. The biggest data set in this project. That pink box is the outside extent of this grid. So when you bring in grid source data, that is how it's displayed. With the ungridded data, we got center lines. With grids, we get an extent box for the full set of the data, and it's a light pink box around the edges. With grids, there's not much you can do. You pretty much can just convert them to SD. We don't do anything like we do with the ungridded data. So to convert a grid to SD, you just click on the grid. You want to click on the grid in the list. The right-click option for the grids doesn't work. You have to do it from over here. So select the grid in the list and right-click and say Convert Grid to SD. When you convert the grid to the SD, you're just going to have a few more options. This is a fairly new box, and I'm not exactly sure what it means, but I haven't had to change it ever, so I'm going to leave that be. An important box here is this Invert Z Data button. For Fledermaus SDs, we expect bathymetric values to be negative, so they should have a negative sign in front of them. If your bathymetric data values do not have a negative sign, you're going to choose to invert them. And that goes for ungridded data as well. I didn't mention that with the ungridded data. But if your data is positive and it's supposed to be in the ocean, you're going to invert the Z's, and it's just going to flip it. The way you'll know you're wrong, if you create an SD file and you get a mountain where you're expecting a basin, just rebuild it and make sure that you invert. This data is actually LiDAR data, so I don't invert it. It is actually positive. The output coordinate system, again, is going to default to the project. Click Next. I leave the color map because you can change it later. And click Next. And finally, you're creating a surface DTM. And for a grid, it will default to the name of the grid. So it's taking my grid name, TopoLight or ASCII, and adding an SD. And I finish. I'm sorry, I'm kind of zooming through now, but I do want to not keep you guys too much past 12 o'clock. So once that creates, I now have an SD file. It's visible in my display here. It could go into Fledermaus, or I can choose to explore it in here. And for that SD file, I again have all these data attribute options down here. So that's a gridded data set. This is some nice LiDAR data around Portsmouth, and you can see there's some water hits over here that weren't cleaned out. The next type of data I'm going to bring in is an image source data set. So images that you might choose to bring into a project would include nautical charts that are saved as a geotiff, or backscatter, aerial images. All of those would be a very useful part of a geospatial project. I'm going to bring in some charts. Again, for images, we bring in geotiffs, bitmaps, and JPEGs. Charts, at least in the US, are distributed as BSBs. I often use, if you're not familiar, NOAA has a chart reprojector tool on their website that will take your BSB to a geotiff, and I use that all the time to convert charts to geotiffs, and I highly recommend it. It's a very useful little tool. So I have a NOAA chart saved as a geotiff, and I also have made it a small portion so that it loads faster for this webinar. To load an image, I'm going to right-click on image and add image data. Go to the file, my charts, and I have a few different charts. Again, remember your source data could be in a different projection. You can bring it in as WGS84, or if you have it in your projection already, you can bring it in as that. It doesn't matter. If it's in WGS84, if you then take it to an SD file, it will reproject. If it's in UTM, it'll go faster. So that's what I'm going to choose. The reprojection does take a few minutes. So I'm going to bring in a small chart that's in UTM. It is in zone 19, so I can leave that be and click finish. All right, and if I turn off the grids and the ungridded, just so we can get an idea, turn everything off. When you bring in an image, the image source data is displayed as a blue box for the extents of the data. And you can see the image is a bit smaller than the full bound, so it's a bit smaller than that LiDAR grid. And it is a blue vector box showing the extent of the image. With images, there are a few more things you can do. You can edit images in DMagic. So I'm very, very briefly going to just bring up that dialog, but we're not going to talk about it too much. If you want to edit the image, things you might want to do to edit it, you might want to crop it to make it smaller, or you might want to add some transparency to it. To edit an image, you, under the source data, select on the image, right-click, and say Edit Image. Okay? Once you do that, DMagic kind of changes a little bit. Everything kind of grays out. The image becomes visible, and you get a new dialog box up here. And this is the image editing functionality for DMagic. It's kind of a separate part of DMagic, so that's why everything else becomes inaccessible. You can only work with the image editing, and when you're done with it, you have to make sure to hit Close Editor. So I can just briefly show you one bit of functionality. So this is my full image. If I zoom in, things will start to render a bit better. If I decided that I really didn't need this full area, I only wanted this main harbor area, I can use the selection tool. I can left click and draw a box, and up here I can choose to crop it. And that's going to crop the image to that size. The way the image editor is a bit different. If I hit Save As here, it's going to save it as a TIFF, or you can choose a JPEG, a PNG, a bitmap. But it is going to save it in an image format, not a Fledermaus SD file. And that's how the image editor differs a little bit. So I will call this, I'll save it and call it small. And once I've done that, you'll see under my images, under my source data, I now have that new TIFF loaded. So you can do a few different things in the image editing. You should explore this. Transparency is a really nice one too. To let you do some really basic image edits. Once you're done with the image editor, you hit Close Editor, and you have to make sure to do that or you won't be able to do anything else. Close your editor. That goes away, and we're back to the source data view. And you see, if you look now, I have two blue boxes because I have a new image loaded. The other thing you can do with the image is convert it to SD, and when you convert it to SD, it becomes visible. So if I right-click on this small TIFF, I can convert image to SD, save it as the same name, and once I do that, the image becomes a Fledermaus GeoImage SD, which is just a specific kind of SD file for dealing with imagery. It maintains all the same image options like transparency and things like that, but it is visible now, so you can see it as part of your data set. So I can turn it on with the bathymetry, and sorry, make the image transparent, not the bathymetry. So that could help you with your projects as far as seeing where things lie. I can make the image transparent and see through to the underlying bathymetric data sets. All right, so that's imagery. The last thing, so we can finish up, is adding a vector data set. Hopefully you guys have it pretty well by now, but it's pretty straightforward getting data in. Right-click on Vectors, Add Vector Data, and choose your file. Vector files include things like ENCs, DXF files, and shape files. They are the vector formats we support in DMagic. I have an ENC file, so I'm going to select on that and bring in one of the ENC files for New Hampshire, which is a .000 file from NOAA. Loads the file up, you click Next. By default, I think all the US ENCs and possibly all of the ENCs in the world are in WGS84. So I just click Finish. And it brings in my final data set. Now you'll see my bounds have grown dramatically, and I have a dark pink box around the edges. The dark pink box is the vector object display. So that is the extent of this ENC. If I turn on the grids now, you can probably see that that is the light pink box, and it's much smaller now than the full bounds of the data set. And for the ENC, the only thing you can do to it is convert it to an SD. So you would click on it, right-click, and convert vector to SD. And then we have a bunch of different individual objects that all make up an ENC. Okay, so that is the basics of DMagic. Just some things to keep in mind. Once they become SD files, they can go directly into Fledermaus. They're ready to go. You can double-click on them here. It will launch Fledermaus, and you can see everything in 3D and go about your business. If you want to create a PFM, I'm just showing you where the functionality is. We're not going to talk about it. You right-click on Ungraded Data, and you build PFM. So all the PFM tools are in DMagic, and they're accessed either by the right-click or from the Tools menu. Once you have an SD surface, you have the option to do a lot of things in DMagic as well. If you right-click on an SD, you can access those options, and they include computing slope, computing rugosity, doing an interpolation, or doing a resample. So those options all become available to you once you create an SD file. With ungraded data, something I forgot to mention, and with any of the source data, if you right-click on it, you can view the metadata for the file. So that is an option for all source data, and that's quite nice to know. So keep that in mind. And finally, with the DMagic project, when you're done with it, there's no save project. You can go to File and Close Project if you like, or you can just close it out, and it will restore in your last state. Something to keep in mind with DMagic projects, as far as memory, the thing that really bogs you down are what SD files are turned on. These are the memory hogs down here. So if you want things to load faster and not crash, you can keep most of these turned off and only turn on the ones you need. If you have a small project, it's not a big deal, but if you're getting into a really image-intensive project, for instance, this is something that will really start to slow you down. So the more SD files that are turned off, the better. Source data, not a big deal, because it's just a nice vector display and it doesn't take up a lot of memory. Before I leave DMagic, I just want to show you one thing in the presentation before we close, but are there any questions, Josh? You can Skype me if we have any. Oh, I closed Skype, so well, if there's any questions, let me actually just scroll through my menu and see if I have anybody.
Yeah, Erin, we have one there from Teresa. She's asking some questions about PFM.
All right, Teresa, I'm going to try to unmute you. So Josh, did she type them in, or are we going to try to unmute?
I answered some of the questions, but she may have some more, so you can just unmute her and see if she has what she has for questions there.
All right, Teresa, I'm going to click on your phone, and it's going to send you a pin that you're going to have to type into your phone. All right. Teresa, are you there?
Yeah.
Hi.
Hi.
What's your question?
The first question, this is Susan actually, not Teresa.
Okay.
But, so the first question is, so for instance, you And you add your source data for the harbor entrance. Now tomorrow you run 4 more hours of data that you want to add to the harbor entrance. I haven't been able to add it to that same folder. It always puts it in some other folder, or it puts it just under the ungridded. So it's not really grouping. So how do you append more data files to that particular folder in your project?
I honestly don't know the answer to that question, but I can find out for you.
Okay. And he answered the question about being able to create an area in DMagic. I guess that capability is not available yet.
I'm not sure what you're talking about specifically.
Well, you had.
Go ahead.
You showed how you could grid up part of your ungridded data.
Mm-hmm.
But let's say you always want to use the same box each time. So
Okay.
I don't believe that you have the capability to generate an area that you can keep and then use it again tomorrow, the same exact bounds.
Right. No, we don't have that. You always have to either draw the box or type in coordinates right now.
Okay. Well, you load an area. Well, when you're gridding, it gives you a screen where you type in coordinates or you load an area that you already have. And I was wondering, how is the data organized? In your directory structure on your hard drive, they're generally in chronological or alphanumeric order, but when you load them, the source data, they don't seem to have any order, although it kind of looked like it started the easternmost and went to the westernmost. But it's kind of difficult because they're always mixed up, the files, and maybe this is something to add to the support as a suggestion. But when you look at your the way your data is listed, the files are listed, they're kind of mixed up, and it's pretty time-consuming to go through and look at your processing log, which is in order, and then you look at the list in DMagic to make sure that you're getting all the files you want. You have to skip all around because they're not in any kind of order.
Teresa, I don't really have any comment. Josh, is Mark still there? Do you have any comment on that?
I'm just wondering how they're ordered.
Yeah, I'm trying to remember. It's just I would have thought the default would have been alphabetical ordering. It's definitely not ordered by time of creation. It's really we just open the directory and you know, as the system gives it to us, that's what we use. I don't think we apply a specific order. It's certainly not user selectable, but it's a good idea.
Yeah, because it becomes very time consuming, and you drop files. Like you want to see D1, D2, D3, D4. Instead, they're all mixed up, even by Julian Day. And anyway, I was just wondering if there was a way to do that.
Yeah, I mean, you probably want time-based order, like basically when the file was closed is probably the order created when you want it, because that sort of would correspond to the survey collection order.
That would, right. Usually it's, yeah, and it's also, yeah, that would be the way to do it. And so when you just add files, is there any sort of filter? I've not been able to get a wildcard to work. Like I only want to look at my .d files, but they're always intermixed with the index files, the ends, and you have to be very careful that you don't select those. So
the best way is what Erin showed, is that you add directories, and in the add directories you can specify star.d star would add all your GSF files that are labeled, whatever file name .d01, .d02.
Yeah, I understand that you can do that when you add a directory, but we more often use, because the way our data is organized on the hard drive, and we build a new PFM each day, but we don't put the files in a distinct directory every day. We just add it to the servop directory, so we have all our data for the month basically in one directory. So we more often use the add a file, and you just like add 10 more files.
Right, and that just uses the system default dialog box. I'm trying to remember if
Add file doesn't have it definitely doesn't have that kind of separate functionality. So if I add files, I sort things by file extension and just add from there. I mean, that's the only way I can think to do it. There is not a file filter.
Oh. How do you even sort by file extension? That you can
just
do that.
Just in Windows Explorer. Let me see if I could.
Oh, yeah. Well, I go in and delete all my index files before I do that, which you don't necessarily want to do that, but.
Yeah. So like for GSFs, because they generate that that index, if I have to add file, I do it by type here, and then I at least get the GSFs on top. You see, just hitting there.
Yeah. I didn't realize that was available. Okay.
Yeah. And Windows. I know you guys probably use Linux. I don't know anything about Linux, but.
Yeah, we're using Linux, so I don't know if that's even available. But if
I think it is.
It'd be really handy. It'd be really handy to add a filter wildcard method for the add file as well. Anyway,
right. We'll keep that in mind.
So how many? I'll probably just send. I need to send from this last survey I was on. I have some other issues.
Support at ivs3d.com.
I will.
Thank you.
Yeah, I'll just send it. And then, how do you recommend? What's your recommendation for how many soundings you want to put in your grid cells?
Mark, any thoughts? I am not a surveyor, so I say 1 to 3, but that's not
basically, I mean, the goal is to produce normally a continuous surface without holes in it. So I just as a general rule, I try and have it, if I'm trying to produce the highest resolution surface possible, I try and have 1.5 soundings on average per bin. So that gives you the absolute highest resolution, but in general, to be a bit better, I would say 2 to 3 gives you a really good surface.
When you're doing, Mark, when your concern is that you're getting good statistics for using various filtering on the surface,
that's different.
Then yeah, that's different.
Then I would say 6 to 7.
Okay, I was just wondering. That's about what
kind of range starts to give you useful statistics. Again, it goes to how much data density you have and what kind of statistics are you actually trying to create versus what kind of resolution you're trying to do. There's lots of, it comes down to what you're trying to accomplish.
Trade-off. Okay. Thank you.
No problem. Do we have any other questions? Easy ones?
Nothing right now. Lisa Robson had a question about the DXF, but I don't think Lisa's here now, so.
Okay.
She was just wondering what version of AutoCAD the DXF.
Oh, geez, I have no idea. You guys would know that better than me.
With any of them, DXF or DWG, 10, 11, 12, 13, 14.
I don't know what version.
AutoCAD 2007 and 2009, I think. So it should be up to the latest ones. So.
All right. Well, if there is not any other questions, I just want to briefly pop up this presentation for a moment. I'm not going to go through it, but if you download the presentation later, at the end of the presentation I added slides with just the basic steps that I went through for create projects, add source data. So there is kind of a visual walkthrough as well if you don't want to sit through the webinar. So I just wanted to let you know that was there. And so in summary, DMagic, it's a tool for organizing your geospatial data. It utilizes the source data to let you see more information about your data. It has some functionality that Fledermaus does not, and that includes the PFM functionality, but also includes some basic stuff like slope and rugosity. And even though we focused on DMagic here, DMagic and Fledermaus work together. So once you create those SD files, or if you create a PFM file, you then take it into Fledermaus to visualize it. If you have any webinar questions, requests, let me know. We are working on the schedule for the next couple of months, so there's nothing up on the website yet. But I do know that there will be a PFM-oriented session in November with Duncan Malice from the IVS UK office, and we will have at least one a month through the rest of the year. So that should be up soon. So please come again. The download will be available shortly. If you're under maintenance, you're just going to have to send me an email because we're going to give you a new download location, username, and password. So you'll get an email from GoToWebinar that says email us for the information, and then we'll send it to you. All right, and if there were any questions that weren't answered, we will we get a copy of those, so we will go through and address them that way. Thank you all for attending, and that is the end of our DMagic webinar. I hope that at least got you started, and yeah, let me know if there's any specific topics you'd like to see. Thank you.